Question 1 says, three forces F1, F2 and F3 act on a body of mass 5 kilograms, and it tells you what F1, F2, F3 are. Find the magnitude of the acceleration of the body. The first thing we need to do here is find the magnitude of the force overall, so the resultant force. So I'm going to add those three things. Easiest thing to do is put them into column vector form. Let me change this pen a wee second. Easiest thing to do is put them into column vector form. So if we put them into column vector form, you have 3 minus 2, and then plus 7, 8, and then plus minus 15, 9. And if you add those all up, you will get your vector force is minus 5, 15 newtons. So that's your force. Acceleration, remember F is vector force is equal to mass times your vector A. So your acceleration is going to be equal to your F divided by your M. So it's going to be minus 5, 15 divided by your mass. And what is your mass in this question? It is 5. So if you do that, your acceleration as a vector is minus 1, 3. And that's going to be meters per second squared. And then you want to find the size. It says find the magnitude of the acceleration. So the modulus of A is what you're looking for. So it's a square root of minus 1 squared plus 3 squared. Minus 1 is squared is 1, 3 squared is 9, 1 plus 9 is 10, so it is root 10, and you can't simplify that down any further, so it's root 10 meters per second squared. Meters per second squared, by the way, you could write ms to the minus 2. This question says, the figure below shows a car of mass 2,000 kilograms towing a trailer of mass 500 along a straight horizontal road. The resistances experienced by the car and trailer are 400 and 200 respectively. The car's engine produces a tractive force of 1,800, so that's your driving force. Find the acceleration of the car and the trailer and the tension in the tow bar. Okay, so you've got your car. You do a wonderful diagram like this for your car. It was 2,000 kilograms, and on it there was a resistance of 400 newtons. You've also got your tow bar. We'll talk about it a wee bit more in a minute. You've got your trailer. It had a mass of 500, and on it there was a resistance of 200 newtons. Sorry, 400 newtons, 200 newtons. Okay, from your car, from your trailer, it's easiest to do it from the trailer. Figured out what way it's going. You'll have a tension in a tow bar which is pulling the trailer. Remember, a trailer has got no driving force of its own. So if that tension is going there from the trailer to get it going, then the tension in your tow bar coming from the car is also going, thrust I suppose, is going the other way as well. So you've got these two opposite things. If the situation changed and the car was slowing down, that means the trailer would also be slowing down. So the only force that can possibly be slowing down a trailer, remember, a trailer doesn't have any brakes, it would have to be reversed. Its tension would have to be reversed, and then tension would also be reversed in for the car as well. Okay, you've also got, almost forgot, you've also got your tractive force, your driving force of 1,800 newtons, and also mark on your acceleration with your double-headed arrow. That's what you've got. Okay, I'm going to say consider the whole system, so everything. I'm going to consider the whole system. I'm going to use F equals ma. This is for me to find the acceleration. So my driving force is 1,800. Going against that, I've got T. Going at for it, I've got T. So these two things cancel each other out, just so I don't have to bother writing those in. And then, but I do have 400 going against it and 600 going against it, and that's equal to my total mass, which is going to be 2,500 times my acceleration. If we work all of that out, and then that just becomes 1,200 is equal to 2,500A, and then a wee bit of working out. Your A is equal to 1,200 divided by 2,500, which is going to be 0.48, and again, meters per second squared. Okay, to get the next bit, I'm just going to look at the trailer. So I'm just looking at so I'll do it again. I'm just going to look at the trailer. So I'm going to circle what I'm looking at. So going forward, the trailer is being pulled forward by T. There's 200 going against it. Its mass is 500, and you now know its acceleration. So we're just going to say consider the trailer, and we're going to again use F equals ma. So let's scoot up the top diagram again. T was pulling forward, and 200 was going against. So that's my overall force. The mass of the trailer was 500, and we worked our acceleration out to be 0.48. So equals mass 500 times my acceleration, which is 0.48. Work that out. That's going to be t is going to be equal to 500 times 0.48, whatever that is, plus your 200, and squeeze that onto the page, and my t is equal to 440 newtons. Question 3, and apologies for how wonky I've scanned this thing in. It says a crate of mass 40 kilograms is held at rest on a rough plane by a horizontal force of magnitude 25. The plane is inclined at an angle of 30 degrees to the horizontal. All forces act in the same vertical plane. The crate is on the point of sliding down, so that's a key bit. If it's on the point of sliding down, that means friction must be acting upwards. So we're going to have our mu r going upwards. It says complete the diagram below showing all external forces. So perpendicular to your surface, you've got your normal reaction. Normal means perpendicular, remember. Continue this line on along, so this line here, continue it on along here to see and draw a wee dashed line. And then draw a vertical line going straight down, and that is your mass. What was the mass of this thing? 40 kilograms. So that's 40g going here. And then this wee angle in here we could also mark on by alternate angles. It's 30 degrees. And this angle in here is going to be the same as this one. If you just learn that that's the way it is, you can get it by just piecing it together. This angle in here is 90. This is then going to be 180 minus 90, minus 30, so it would be 60, and then this angle in here would be 90 minus 60, so it's going to be 30. But if you just learn off, folks, in these questions, do that again, it's a mess. You just learn off in these questions, if that's your angle, it's at an angle theta. There's your vertical, there's your normal reaction, and if you do that wee dashed line, that's always going to be theta as well. So this angle and this angle are going to be the same. That's so much easier just to learn that off, that's going to be they're going to be the same. Okay, let me get rid of that. Okay, I think we've got all of our angles, have we? Yep, all of our forces. We have indeed. I'll just mark that on. It's 40g newtons, and we're to find the coefficient of friction. So first of all, I'm going to go perpendicular, resolve perpendicular to my plane, and r is the only thing going in this direction here. R is the only thing going in this direction. All the other forces are going in this direction. So I'm going to have my R is equal to, the easy one first of all, I have 40g cos 30. And then I've also got 25, and it would be sine 30. And then if you do that, and I'm going to be using this R, so I just put all the digits, I've got my calculator onto the page here, 351.9819, and next thing we're going to do is resolve parallel. Sorry, I should have said resolve there. Resolve parallel to the plane, and we will set going up the plane. I've got mu r, so let's go back to that. I've got mu r, and also pushing me up the plane is 25 cos 30. And that is equal to, the only force down the plane is your component of the weight going down the plane, which is 40g sine 30. Let's see if I can get that all on screen at one time. You can see it. There, you can see it there. So going up the plane, you've got mu r. You've also got this. If you pull this 25 down to here, so 25 cos 30, that's also going up the plane. And the only thing going down the plane is a component of the weight, so 40g sine 30, pull me down this way. Okay, just a wee bit of rearranging then. I've done this. I'll do a couple of steps to this. My mu r then, first of all, is equal to 40g sine 30 minus 25 cos 30. And then my r, my mu that I'm looking to get then, is equal to all of that divided by my r. All divided by my r, and again I've used that as good a value as I could get for my r, which was 351.9819583, and I've got my mu is equal to, I think it said in the front of the exam, you have to check that, at 3 sig figs. And there we go. Okay, this question says ball is thrown vertically upwards with a speed of 20 meters per second. 3 seconds later, a ball is thrown vertically upwards from the same point with a speed of 22 meters per second. Find how long it takes from when the first ball is thrown until the two balls collide. So I've got my first ball and I've got my second ball. And for my first ball, I'm going to say it's thrown up with a speed of 20. So I would put the arrows on, it just makes life easier. Your time, I'm going to call it capital T. My A is minus 9.8 meters per second upwards. That's the acceleration due to gravity. And S then is equal to, and remember the formula for S is it's UT plus a half AT squared. And we're just going to fill that in with whatever we get. Sn is equal to 20 times big T, and then a half times minus 9.8 is going to be minus 4.9 times T squared. Okay, and we will be coming back to this thing very soon. For the second ball, so it says 3 seconds later, a second ball is thrown up with a speed, so greater speed of 22 meters per second. Time is, if my original ball has gone for capital T seconds, this one has gone for 3 seconds less, so it's capital T minus 3. My acceleration is still minus 9.8, and S is equal to UT plus a half AT squared. So let's just fill that in. S is equal to 22 times T minus 3, and then a half times the minus 9.8 is minus 4.5 times your T squared, which is T minus 3 squared. And then we'll just tally that all up. So if we do that out, you're going to get S is equal to, that's going to be 22T minus 66 minus 4.9, and then the T minus 3 squared is going to be T squared minus 6T plus 9. And then we'll go on from there, tally it up again. So what do we get if we tally this up? Well, here, I'll just multiply it out. Actually, I'm not tally it up just yet. 22T minus 66 minus 4.9T, and 4.9 times minus 4.9 times the minus 6 will be plus 29.4 times big T, and then it will be minus 4.9 times 9, which is minus 44.1. And then what we want to do is just put the two distances equal, so put S equal to S effect. 20T minus 4.9T squared is equal to 22T minus 66 minus 4.9T plus 29.4T minus 44.1. And what you should notice here, oh, that should have been a 4.9T squared there. 4.9T squared, they will disappear. So that's nice. We get rid of the quadratics. And then if we just tidy up, left hand side doesn't need much tidying up, it's just 20T. The right hand side does need a bit of tidying up. It's going to be 22T plus 29.4T is going to be 51.4T. And then minus 66 minus 44.1 is going to be minus 110.1. And again, bring all the T's to one side, fire the 110 over to the left hand side. You have 110.1T is equal to 31.4T, and then T is equal to 110.1 divided by 31.4, and I'm going to write that as an exact value, which is 110, oops, rid of that, 110, 1101 over 314 even, so that's an exact value, but for the purpose of your question, give an answer as 3.15. And that's the seconds, and that's the 3 significant figures. But for the next part of the question, we'll use this exact value. The next part of this question says, find the direction which the first ball is moving when the two balls collide. So we're going to find the velocity of the first ball when the two balls collide, and we know what the time at which they collide. So this is me looking at the first ball again, and we know it was initially thrown up with a velocity of 20 meters per second. The time, we have now calculated that time. I'm going to use the exact value, 1101 over 314. My acceleration is still negative acceleration due to gravity, so minus 9.8 upwards, and we want to find our velocity. So it's the easiest of our SUVAT equations. Is v is equal to u plus at, so it is equal to v is equal to 20 plus minus 9.8 times 1101 over 314. And when you work that out, your v is equal to minus 14.4 meters per second. Okay, so the question didn't actually ask us to find the velocity. It says find the direction which the first ball is moving when two balls collide. So if we assume 20 meters per second, positive 20 velocity is moving upwards, then a negative velocity of anything is moving downwards. So we'll just say, so the first ball is moving downwards. Done. Okay, right, the most difficult question on the paper. This really is quite a confusing one, I think. It says a ball bearing is dropped from height onto a horizontal metal plate. Each time the ball bearing strikes a metal plate, it rebounds with its direction of motion reversed and its speed reduced. On the axis below, sketch a velocity time graph of the ball bearing until it strikes a plate for the third time. Okay, right. First of all, I'm going to do, it's dropped, so it starts at the origin, and I think that's a key point, that it is starting from the origin for one of your marks. And then it's going to have, pardon me, it's going to have it's going to speed up until it strikes. So this is the first time it strikes. What happens then is its velocity then changes direction almost instantly. It'll be some wee period of time where, a tiny wee period of time where it changes direction as it's contacting the wall. But I'm going to put its speed then, its velocity is now going in the opposite direction, so it's down here, and I'm going to make it half as big just on my diagram. So it's not the same distance from here to here, it's the distance from here to about half of that. So very roughly I'm going to put it here. And there's going to be an ever so slight gradient down to that. Okay, now the key thing is then, it's then going to be this next wee bit then, it's going to go up to, this is now at starting off, and it'll go up to a certain, it'll go back to 0. So this is where it's at its maximum height, and then it starts to, so it's slowed down effectively, velocity slowed down, and then it's going to speed up again, and then it's going to hit the ground again. So this is my second bounce. I haven't really left myself much room here. And then the same thing's going to happen. So this speed distance here, I'm going to half it down to here, for example, and then this will be my third bounce. Oh dear. And this will be my third bounce, and that is it. Okay, so what I imagine, I'm just guessing here, I'm imagining what they're looking for. First of all, you're starting at the origin because it's being dropped, and then these lines are parallel, and also then that the distance is, the gap distance then, it's going to be a shorter distance, and it's going to be a shorter, or height I should say, and that's it. Okay, next one is another type of question I don't like. It says Kevin is doing a geography project about weather. He has organized his data in a spreadsheet using one row for each day's results. The table below shows a part of Kevin's spreadsheet. So you've got the mean temperature here, you've got the mean temperature, you've got the rainfall, you've got mean wind speed, sunshine hours. This is in a day, remember, which is going to be important. You've got mean pressure and mean relative humidity. What you've got to do in this question, it says identify 3 reasons why Kevin needs to clean his data. So cleaning your data means you've got to get rid of any data which there may be problems with, or you think that there are problems with. So the first one we come to is this one in row 3, and the reason is have a look at the mean relative humidity. They put AB, so it doesn't mean anything here for this one. So there's a bit of data which doesn't have any real meaning. Next problem is, which is probably the hardest one for you to spot, is this one. And this is sunshine hours. This is he's organized his data using one row for each day's result. There aren't 92 hours of sunshine in a day, so what must have happened? This is a mistake in this data. Somebody has recorded something incorrectly. Maybe it should have been 9.2, maybe it should have been 2.9, who knows what it should have been, but we do know that it's definitely incorrect. There's not 92 hours of sunshine. And the last one here, we've got a missing value. So there's 3 value in row 9. So row 3, problem we have AB. Row 6, you've got 92 hours of sunshine, which is not possible. In row 9, you've got a missing value. So write those up just then. Just say those 3 things. Clean row 3 as it doesn't have a mean relative humidity. Clean row 6 as it says there's 92 hours of sunshine in a day. And clean row 9 as there's a missing value. Next part of this question says we've got Kevin's got a box plot drawn for the rainfall, X millimeters for all the data in the spreadsheet. Kevin claimed that one value was an outlier and marked it as X. So this value here he has said is an outlier. An outlier is defined as a value which is outside the range. And I'm only going to look at this one here because it's his is on the upper part of it. So it's Q3, which is your upper quartile, plus 1.5 times your interquartile range, which is Q3 minus Q1. Show that Kevin's claim is not correct. So first of all, from our table, let's read off what we get for our Q3, or from our box and whisker. If you read off from what he has got, we've got 5.2 for your upper quartile, and you've got your lower quartile is 2.5, and then your Q3 minus your Q1 is 5.2 minus 2.5, which works out to be 2.7. So that's your interquartile range. And then we can work out this value of this thing that I've got circled. So Q3 plus 1.5 times Q3 minus Q1. So we'll just work that out. Q3 plus 1.5 times Q3 minus Q1 is now equal to 5.2 plus 1.5 times 2.7, and when you work that out you will get 9.25. So that means all of your values would need to be below 9.25, and let's look at our X value. Our X value is 8.2, 8.25. It's definitely going to be below 9.25, so we'll just say so X is not outside this, so it should not be removed. Okay. Question 6 says an airline operates between Belfast and Edinburgh. Each passenger is allowed to check in one piece of luggage, one piece of whole luggage, I should say. For one flight, the mass X of the whole luggage for each of the 220 passengers. So I'm going to write these things down when I come to them. 220 passengers, and the results are shown as below. So sigma X is 2214.44, and sigma X squared is equal to 31454.76. Calculate the mean and the variance for the masses of the whole luggage of the 220 passengers on this flight. So your mean, and what we call our mean is X bar, is equal to sigma X over N. So your mean is 2214.44, all divided by 220. So your mean works out to be 10.0656. And so on and so on, but to, what are we doing? 3 sig figs, 10.1 kilograms to 3 sig figs. Your variance then is equal to, the formula for it is sigma X squared over N minus, and your mean, sigma X over N squared. So your variance is equal to 31454.76 divided by your N, which is 220, minus your mean, which is 2214.44, all over your 220. It was being squared. File that into your calculator. You get 14196.30. which is to 3 sig figs 14200, and that would be its variance, so it's strange, but it's kilograms squared, and that's to 3 sig figs. Next part of this question says, in addition, each passenger is allowed to carry one piece of hand luggage on board. The mass y kilograms of hand luggage of each of the same 220 passengers is also recorded. Some further summary statistics are as follows. So you've got SSY is equal to SSX, SXX, SYY is equal to, you've got all these things, and it says calculate the product moment correlation coefficient between the masses of hand luggage and whole luggage for this flight. So from your formula booklet, thankfully, your product moment correlation coefficient is, you're told, is SXY over the square root of SXX SYY, and then we can fire all of that in. So your S is your product moment correlation coefficient then is equal to, and it is just firing values in. That's all you're doing here. So it's 196.205 over the square root of, and it was 9165.012 times 2804.465. Fire that into your calculator, and you will get your R is equal to, and it's 0.0387, and that is to 3 sig figs. The last part of it then says comment on the value obtained. So your value was this thing here. It was fairly close to it's fairly close to what? Fairly close to 0. So it shows there is little correlation. There's hardly any correlation at all. Correlation between the mass of hand luggage and the mass of hold luggage. Okay, it doesn't ask you to give any reasons why or anything like that, so you just have to recognize that it's such a small value, so that indicates that there's little correlation between the two things. Okay, next question says, it is known that 1 in 6 seeds in a large batch will not germinate when planted. Write down the probability that the seed from the batch will germinate. So probability that it germinates in is going to be, if it was 1 in 6 will not germinate, that means 5 over 6 will germinate. And that's it done. 1 mark done for you already. Next part of the question says 12 seeds are shown. Calculate the probability that exactly 9 of these seeds germinate. So X is distributed, it's binomial, and my N is 12, and the probability of success, so the probability to germinate, is 5/12. And you can use your calculator, but for this one I think I'm not using my calculator. Probability X is equal to 9 is equal to 12C9 times probability of success, 9 successes, so 5 over 6 that should be, 5 over 6 to the power of 9, and if 9 succeed, then the failure ones will be, there'll be 3 of them, and then you just file that into your calculator, and I got 0.197395724, so the 3 sig figs, 0.197 to 3 sig figs. Next part says calculate the probability that at most 10 of these will germinate. So we're looking for the probability that X is less than or equal to 10. Okay, right. Back in the old days, back before people had the class with calculators, this was very, very hard to, do, very easy to make a mistake anyway. You would have had to have worked this out the long way, but with the new calculators, there's a function on it which you need to familiarize yourself with, which is binomial CD. Okay, so that's like your cumulative probabilities basically. In this then, you put in X equals 10, you put in your N, I think it's capital N, they put it on the Casios, N is 12, that's your number of trials, and your probability is 5, 6, so how you do 5, 6 is you write in on that 5 divided by 6. So you get to, on my one it is, I'm doing menu and then 7, there's like a the wee option when you hit menu, there's one wee box that looks like this. That's the one that you're hitting. And then, so whatever one that is, in mine it's 7, some other people know it's different. And then I have to scroll down to get the binomial CD, press it, and then you hit variable, and then your X you put in 10, press equals, your N you put 12, press equals, and then your P, you're doing 5 divided by 6, press equals, and then press equals again, and it will tell you that that is equal to 618,667, and so on. So to 3 sig figs, 0.619 to 3 sig figs. Okay, next one says find the most likely number of these 12 seeds will germinate. So first of all, you find your expected number. So that's 12 NP, which is 12 times 5 over 6, which works out to be 10. Now that's not you done, but that definitely will get you a mark if you show that. But you want to test around that. So test the probabilities around this thing. So you're testing X is equal to 9, X is equal to 10, and X is equal to 11. So just pick the values around it. More like it's going to be 10. More often than not, it is just the same as the expected value, but we will see. So we're going to find the probability X equals 9, and I'm going to use my calculator to do this. I use my used the formula for the binomial earlier on, but I'm just going to do these using a calculator. So again, go into the same place you did, go menu, and for me it was menu 7, but you're going to binomial PD this time. Binomial PD, and this time you're going to variable again, and your thing is set up fairly similar. Your X value but changes then for this one. X is going to be 9, this one's going to be X is going to be 10, this one's going to be X equals 11. The N is the same as it was before, so N is still going to be 12, your P is going to be 5 divided by 6. So put in the 9 first of all, and I got that was the 3 sig figs 0.197. Let's go, just press equals again, and it takes you back to that binomial PD option. And then I'm changing my X to 10. And my probability that X is a 10 is 0.296, again the 3 sig figs. Press equals again, change your X to 11. And then press equals a couple times to get down. Your probability is 0.269 to 3 sig figs. So you can see X equals 10 has the biggest probability. So 10 is the most likely number of seeds. Okay, done. And if you think about that one, it says 5 out of 6 seeds germinate. So if you do 12 seeds, you'd think the majority of them will germinate, and sure enough, 10 was the most likely probability. So it does make sense. Okay. Last question in the exam says the figure below shows a Venn diagram with 2 events A and B and probabilities associated with these events. Show that X plus Y equals 5 over 12. Okay. They've covered all the possible outcomes. You have X, you have a half, you have Y, and you have this, and all of the possible outcomes adds up to 1. So we're just going to add those in, say that. So X plus Y plus a half plus 1 over 12 adds up to 1. That means X plus Y is equal to 1 minus a half minus 1 over 12. And if you tidy it up, that's X plus Y is equal to 5 over 12 as required. Next part of the question says, given that the events A and B are independent and the probability of A is greater than the probability of B, we'll forget about that for a minute, find the values of X and Y. So given that they're independent means, so if independent, that means your probability of A times your probability of B is equal to your probability of A and B. So that means your probability of A was x plus a half. That's going back from that table, sorry. A is x a half, the whole of that thing. Probability of B is y plus a half. And your probability of A and B is the overlap, so it's just a half. So that's where this comes from. I'm going to write that down on the next page as well, so then we can work with it. We have x plus a half upon y plus a half is equal to a half. And we'll just multiply that out. You're going to have xy plus a half, y plus a half, x plus a quarter is equal to a half. Bring it all to one side, put it equal to 0, tidy up, you'll have xy. Here, I'll write my x term, I don't know why I put a second there, plus a half x, plus a half y, and minus 1/4 is equal to 0. I really should multiply 3 by my 4. I didn't do this. I don't know why I didn't. You know what? I will keep doing it the way I was doing it. It's fine. What do we have? We also know x plus y equals 5/12. So write that in. We'll call that equation 1. Say we also know x plus y is equal to 5/12. So that means we'll rearrange and make y the subject here. So y then is equal to 5/12 minus x. And then we will sub that into equation 1. So sub into equation 1. And you're going to have x times 5/12 minus x plus a half x plus a half times 5/12 minus x. Then minus 1/4 is equal to 0. This is ugly, very ugly, but it's doable. We're just going to work through it. We're going to have 5/12x minus x squared plus a half x plus 5/24, that'll be minus a half x again, and then minus a quarter is equal to 0. And if you have a look at that, is there anything nice that happens here? You're just left with, tidy that up, you're going to have 5/12x minus x squared minus 1/24 is equal to 0. I would bring it to the other side to make the x squared term positive. So you'll have x squared minus 5/12x plus 1/24, and multiply through by 24. You're going to get 24x squared minus 10x plus 1, and that's now a nicer equation to work with. This one actually does, when looking at my answers, this factorizes. In the heat of an exam, I don't think I'd bother trying to factorize. I would probably just use my quadratic formula. So x is equal to 10 plus or minus 10 squared minus 4 times my a, which is 24, times my c, which is 1, square root of all that, all divided by 2 times my a, which is 24. And a wee bit of working out, that will give me x is equal to 1/6, or x is equal to 1/4. Okay, now it tells you something about the probability, something being greater than something else. Yep, it tells you probability of A is greater than probability of B, which means your x value has to be greater than your y value. So we'll maybe come to that in a wee second. Right, here we'll just say when x is equal to 1/6, y then is equal to, remember your formula for your y is equal to 5/12 minus 1/6. So 5/12 minus 1/6. So y works out to be 1/4. Or here, when x is equal to 1/4, y works out to be 5/12 minus 1/4, and y works out to be 1/6. Okay, now remember what I've just said, your x value had to be greater than your y value. So in this one, this option, your x value is not greater than your y value, so that's not going to be our answer. So it has to be, this has to be your answer. So just say, as probability of A is greater than probability of B, that means your x must be equal to 1/4 and y must be equal to 1/6. Okay, and I think that is us done. This is the end of the question paper. Happy days. That's all done.